Welcome back to the deep dive. When most people think about the AI boom, their minds go to chips or software, maybe venture capital.
Right, the flashy stuff.
Exactly.
Yeah.
But today, we're going deeper. We're looking at the single most critical and probably least discussed foundational layer of this whole revolution: electricity.
It's the ultimate hidden input, and, it's also the ultimate choke point.
That's a good way to put it.
And the popular conversation, it's always about the volume, right?
Yeah.
This idea that AI consumes too much power.
Yeah, you hear that everywhere.
But that framing is actually missing the much more profound policy and infrastructure shift that's happening right now.
That's it. So our mission today, it's not really to analyze the gigawatts AI consumes, and that volume is staggering, don't get me wrong. It's to understand how that existing power supply is now being managed, and more importantly, how the rules for its distribution are being rewritten under just intense pressure.
Okay, let's unpack this, because what really stood out from the sources we looked at is that we are witnessing this quiet re-engineering of the power grid's operating system.
Yeah.
It's not about adding more lanes to the highway. It's like creating a priority toll-free fast lane for certain customers.
And what's fascinating is how quickly this is becoming institutionalized. The core issue isn't just power volume anymore. It's the allocation rules, the sort of implicit contracts of public utility that are being redefined in real time.
So this whole deep dive is about prioritization.
All about prioritization, why the system is being forced to do it, and, what that means for your reliability and your wallet.
So to see how this is becoming, formalized, we have to look at a really specific regulatory event in the U.S. The news was all about the U.S. Federal Energy Regulatory Commission, FERC, stepping in. And FERC is basically the ultimate referee for the interstate power system. They directed PJM, which is the largest grid operator in the U.S., covering 13 states, D.C.
Serving something like 67 million people, right?
That's it, a huge number. And they told them to make a radical change to how they handle connections for what they call large load consumers.
Which is code for AI data centers.
It's pretty much all AI data centers.
And the intervention itself, that's the real headline here. FERC looked at PJM's existing rules, the tariffs, and they called them, and this is a quote, unjust and unreasonable.
That is incredibly strong language from a regulator.
It really is. So what made the status quo suddenly so bad?
It was just being overwhelmed. The concern wasn't just that data centers use a lot of power, it was the sheer velocity of the new demand.
The speed of it.
The speed. It requires massive new investment in generation in transmission lines. And FERC decided the current rules were creating unacceptable risks to grid reliability for everyone else.
For those other 67 million customers.
And that it could dramatically drive up power prices for all of them.
Now, in the sources, this term co-location keeps coming up. It's the specific method these data centers are using to get their power, and it's what FERC is now trying to regulate. Can you explain what that looks like?
Yeah, so think of the power grid like a public road network.
Okay.
Co-location is like building your factory right next to the on-ramp, or even in the parking lot of the power plant itself.
So you skip all the traffic?
You skip all the traffic, you avoid the bottlenecks on the main transmission grid, those long-distance public lines. You're basically getting your power directly from the source.
That just sounds like smart business, Technical optimization.
Yeah.
If it's more efficient, why would FERC step in and call it unjust and unreasonable?
Well, it would be if you were talking about a purely private, closed system.
Right, if it was just one company optimizing for itself.
Exactly.
Mm-hmm.
But it's not. The power system is a public utility. So the consequence of that efficiency is you're quietly creating this sort of priority lane that doesn't pass through the public system.
A bypass.
A total bypass. So the optimization for one customer can become a real burden for everyone else who has to rely on those main congested lines.
So the regulator is basically formalizing the rules for this priority lane. They're moving it from a clever workaround to an explicit institutionalized system.
That's it. It's a huge policy shift that, like you said, almost nobody is talking about.
It feels like the moment the rules become official.
They do. It signals that regulators see that this priority access is necessary to keep the AI investment flowing, but they also have to, manage the fallout for the public.
Here's where it gets really interesting for me. Why are these companies even forced to create these exception routes, these priority lanes in the first place?
Yeah.
It comes down to this core structural mismatch that the analysis calls shear, a velocity mismatch.
It's a fundamental non-symmetry. You have the digital economy and the physical infrastructure moving at completely different speeds.
Okay, break that down.
AI investment, it moves at the speed of capital. Decisions for huge Multi-billion-dollar data center campuses. They're made on a quarterly or yearly cycle.
And they want to build them tomorrow.
Almost. Deployment is like 12 to 18 months, max.
And the power grid to support that?
The physical infrastructure, building transmission lines, getting permits for new power plants, that moves at the speed of bureaucracy. We're talking half decades, maybe a full decade.
So 7 to 10 years just to build a new power line.
At least. So you have one side on an 18-month clock and the other on a 7-year clock. That speed difference, that structural shear, it creates impossible pressure on the system.
So the system has no choice but to find a workaround.
It's forced to find these exception routes like co-location. It's not really a choice, it's an adaptation just to survive the pressure from this massive, fast-moving demand.
So the speed of the technology is literally writing over the traditional rules of a public utility.
It is. The demand is rewriting the grid's allocation operating system.
And that leads to what the sources call a compatibility nightmare.
Precisely. Because the technical solution, giving priority supply to avoid bottlenecks, is, economically and systematically correct if you're just optimizing for growth. But it runs headlong into the public's idea of fairness. Of what a public utility is supposed to be.
The public expects the grid to be first come, first served, or at least allocated based on public need, not on who has the fastest private capital.
That's the tension. You have this perfectly optimized technical fix, but the second the public realizes they might be subsidizing it or sacrificing their own reliability for it, the whole thing's legitimacy just falls apart.
And yet we're not really seeing widespread outrage, at least not yet.
Not yet.
And this brings up another concept from the sources. Calcification, this striking lack of public debate.
And that's what's deeply concerning to energy analysts. This change directly affects who gets priority access to a fundamental public resource. But it hasn't become a big political issue. It's all happening in complex regulatory filings, tariff negotiations.
Places most people never see.
Exactly, far from the public eye. The costs are sort of diffused, hidden in jargon. So analysts see this silence as a precursor to a potential backlash.
Meaning, once the costs and the reliability issues become undeniable, that's when the political fight really begins.
Absolutely. I mean, PJM has already raised major concerns about this. Once those costs really start showing up clearly in your electricity bill, or when the system gets stressed during extreme weather, that's when this moves from a regulatory debate to a full-blown political battlefield.
Okay, so let's connect this abstract structural stuff directly to a listener's life, the life impact outlook. How does this new system actually show up for people over the next, say, 5 years?
The analysis points to two main things that will affect you immediately. The first is increased electricity prices, and the second is this widening gap between different regions, a tiered power system.
Let's start with the money. That's what everyone feels first.
Right. So when these huge data centers connect, they're not just using spare power. They force utilities to make massive new investments in generation and grid upgrades.
We're seeing this in places like Georgia, Texas, and especially Northern Virginia, right?
All of them. Huge capital outlays for new power plants and transmission lines.
And here's the fairness issue made real. The sources say the costs for these huge expedited upgrades are often passed on to the region's general electricity rates.
Right, they're socialized. So an AI firm needs a $500 million substation upgrade now. The utility builds it, and that cost gets spread across every single ratepayer in the region.
So the benefit that guaranteed power is concentrated on the data center, but the cost is spread across everyone.
Everyone. Residential customers, small businesses. You might see it as a small uptick in the basic service charge or an infrastructure fee on your bill.
So if I live in Philadelphia and PJM has to upgrade lines in rural Pennsylvania for a new data center, some of that cost could end up on my bill.
That's precisely how it works. It's an invisible stratification. The financial burden gets distributed across millions of people who see none of the direct economic benefit.
Which leads right into that second point, this idea of tiering in the power system based on where you live.
Yeah, it's powerful, and it's going to change regional economies. You'll have two kinds of regions emerging, the haves and the have-nots.
So Northern Virginia Data Center Alley is a have region.
It's the ultimate have region. They get priority power access. They get the tech jobs.
Yeah.
But the residents there will also likely face higher utility fees because of the constant infrastructural investment required to serve that one industry.
And the have-not regions, the ones that miss this AI investment wave.
They face a tougher problem. They might still get higher fees from just trying to keep the regional grid stable, but without any of the jobs or economic benefits. And it limits their future.
Yes.
It constrains their options. It becomes harder to attract future businesses or manufacturing if your region is seen as power constrained. Your digital and economic future gets a little narrower.
And you mentioned this isn't just an American issue.
No, the pattern is easily imported. The sources use Japan as an example. If data centers all cluster around, say, Tokyo, then the rural areas could face disadvantages in both power capacity and pricing. It limits their choices.
So this normalization of preferred customers and
Mhm.
special contracts, it fundamentally changes what we thought a public utility was.
It really does. Because when the demand pressure is this extreme, the system has no choice but to institutionalize priority. This isn't just abstract energy policy. This is about everyday choices.
How much you pay to live and run a business.
And your future access to digital services. It changes the economic map of where you can afford to operate.
Okay, so if we synthesize all of this, the short-term story is AI investment and jobs. But the real core takeaway is that the regulatory system has already started to redesign the rules for who gets power first.
And if you connect that to the bigger picture, the global competition for AI dominance is now fundamentally a competition for power allocation. Reliable electricity is the ultimate strategic resource.
And crucially, the actual stakeholders in the cost and the reliability are largely outside this decision-making process.
Completely outside of it. The decisions are being made quietly in those regulatory bodies, driven by this pressure of fast-moving capital. The outcome isn't just more consumption. It's a tiered system for a public resource.
So in this new era where power is the ultimate strategic asset, we have to ask the question that the source material ends with.
Yeah.
Who gets electricity first and who decides?
And let's leave that question open for you to consider. Because as you watch your utility bills and you observe how all this plays out, you'll see how priority and fairness and public infrastructure all intersect. The true cost is always surface, eventually.